Alright guys, so here are my notes on the division property of exponents. It's going to be similar to yesterday when we multiplied, but today we're going to be dividing. My learning target is I can use the division property of exponents to simplify factors with the same base. So things are going to have the same base today when I simplify them. Now before we get into the notes, I would like you to try these 3 questions. Try them on your own, pause the video, and when you're done, unpause it to check. Alright, hopefully that was enough time for you guys to unpause it. 7 divided by 7 is just 1. 5 divided by 5 is just 1. And this is the tricky one, I'm assuming, for some of you. I'm assuming some of you put x. That's not the case. Anything divided by itself is 1. And that's actually the fact about dividing that I want you to remember. Anything, even letters, divided by itself is 1. So when I look down here at this, there's going to be a way that we can simplify this today where there's less writing and where I really don't have to do that much arithmetic or mathematical work. So let's write this out and then we'll talk about what more we could do. So if I have 5 to the 7 on top, how many 5s are there? Obviously 7. There's 6 and one more gives me 7. And how many 5s are on the bottom? Obviously there's 4. So what I'm going to do is I'm going to use this fact to help me simplify. 5 divided by 5 is 1. Because there's really 5 divided by 5 a bunch of times on here. Here's a 5 divided by 5. Come back to this. So that 5 divided by 5 is 1. This 5 divided by 5 is 1. This 5 divided by 5 is 1. This 5 divided by 5 is 1. Can I do that again? Obviously not, because there's no more 5s on the bottom, so we're going to write what's left. 1 times 1 times 1 times 1 is 1 times 3 5s. Now obviously there's a bunch of 1s, but I don't really need to put that. It's not going to change anything. What I need to put are all the 5s that are left. So how many 5s are left here? Obviously it's just 3, so we write it as 5 to the 3rd. So this first example, if I have 3/5 7 times on top and 3/5 5 times on the bottom, how about this question? How many 3/5, if I were to write all this out, could I cross out? Well, obviously I could cross out 5 of them, because after that there'll be no more to cross out off on top. So how many more 3/5 will be left up on top after I do all my crossing off? 3/5 twice. Okay, and I say in this example the base for both numbers is 3/5. Alright, here's one that's a little bit more confusing for some people. I have x squared over x to the 8th. So if I were to write this one out, let's write this one out together, guys. 1, 2, 3, 4, 5, 6, 7, 8. Alright, so now if I were to write this one out, and I were to do all my crossings out like I said before, cross off 1, cross off another one, what's left? Well, obviously there are 6 x's left. But this one's a little bit different than these last 2 examples that we just went over. Can anyone tell me why? Well, it's because these x's are down at the bottom. You cannot just put x to the 6th. That would mean that they're up on top. You need to put x to the 6th on the bottom of a fraction. Now, because there's 1 times 1 left on top, you can put a 1 up there. So even though there are more x's on the bottom, that's okay. Just divide out as many x's as you can, and whatever's left is your answer. Okay? So on the next page, something else that's really confusing is this guy. So let's write this out. I have 2 7 times. And then I have 4 twice. Now, in these numbers, or in this example, these numbers don't have the same base. But you could simplify it a little bit by saying, well, if I wanted to cross off a 4, what can I cross off up here? Isn't 2 times 2 4? So can I cross off like that? And then if I did another 4, how many 2's do I have to cross off again? 2. And how many 2's are left? 3. So it is 2 to the 3rd. So we can switch them to make them have the same base if we really wanted to. All right. So I have a bunch of examples down here for you guys to try. Would you please try these and unpause the video when you think you're done? All right, so 22 is pretty easy. It's -5 a bunch of times. How many times is it? 8. 23 is going to be 1 over 13 to the first, because there's one more on the bottom. Where are there more x's in example 24? On top or on bottom? On top by just 1. So you could write x to the 1 or just x. This one's going to be a little bit confusing. Let's write it out. I already wrote out 5. And 27 on the bottom. This is just like this example right here. So that being said, if I did 3 times 3, that gives me 9. 9 times 3 gives me 27. So if I cross off these 3, I could also cross off the 27. And how many 3's are left? 2. These 2 were to make sure that you understand like factors. You can only cross off like factors. So if I wanted to cross off 2 3's down here, I could also cross off 2 3's up here. And I would have 3 to the third left. Times, if I did the same thing with the 2's and crossed off 3 of them and crossed off 3 of these, how many 2's would be left? 5. Same thing right here, -2, there would be 2 left, and then 195 left. So I could say 95 or 95 to the first. All right, so I've seen a problem like this a couple times. I want to make sure that we know what's going on here. All you need to do is put this 3 over x to the 8th over 1. So now it says 5 times 3x to the 8th, which is just 15x to the 8th, over x to the third times 1, which is x to the third. So now that I have that, is there any crossing out or any simplifying I could do? I could cross off 3x's down here and 3x's up there, and what would be left? Well, 15 would be left on top, and then there would be 5x's left on top as well, because these 3 taken away from 8 is 5. And that's it. You could write over 1. It's not necessary, though. On the next page, would you please try this one, pause your video, and then when you are done, unpause it to check and see how you did. All right, so hopefully that was enough time for you to pause it and unpause it. Remember, all I need to do is take this and put it over 1, and then go 5 times 11x to the 4th, which is 55, x to the 4th, over x to the third times 1 is just x to the third. So now, is there any more simplifying I can do? I can cross off 3 of these x's with 3 of these, and all that's left on top is a 55 and 1x. So you could put x to the first or just x. On the bottom, it would just be a 1 or nothing at all. So there's your answer. Now, it gets a lot trickier when they put numbers in front of the variables again. We did that last class. Do you remember what these numbers are called? Like this 3 and this 12. They're called coefficients. Coefficients. This is going to be very similar to the steps that we needed to do last notes, the multiplication law of exponents. So, my big tip for this is to just know that this is going to be a fraction. If I gave you a whole entire just test full of things that look like this, 6 over 8 is equal to 2 over 4 is equal to 5 over 10 is equal to, let's say, 8 over 20 is equal to. You could do this. This is pretty easy. 2/4 reduces to 1/2. Or 5 over 10 also reduces to 1/2. Or 8 over 20, 4 over 10, which reduces to 2 over 5. That's really the hard part of this problem. Can you reduce a fraction? So, can I reduce 3 over 12? Well, if I divide them both by 3, I end up getting 1 and 4. So then all that's left is x to the 7th over x to the 3rd. And that's the same exact problem that we did, say, right here. X to the 5th over x to the 4th. So, where do you have more x's, and how many more do you have? Well, obviously you have more x's on top, and there are 4 more. So there's your answer. Okay, just make sure that you reduce that fraction first, and that's it. So let's take a look at this next one. I'm going to have a fraction. If I divide both of these by 4, I'm going to reduce it, and I end up getting 4 over 1. Now, even though you knew that might have been 4, I want you to write it as a fraction and then erase it after, because that's really going to help for more difficult ones. Now, where do you have more g's? On top or on bottom? Obviously on top by 3. Because there's nothing else really on the bottom other than that 1, you could just rewrite it as 4g to the third, but I would also accept this as an answer. Okay? So let's try one that's a little bit harder right here. Write out my fraction bar. Let's divide 9 and 18. What could I divide them both by? Obviously it's 9, so it turns into 1 and 2. And now let's just go down the line and say, where do I have more x's? Well, I have more up on top by 6. Where do I have more y's? On top by 2. And where do I have more z's? On top by just 1. Remember, you could write z or z to the first. On the next page, I have 2 for you to try. Would you please try both of these for me? Pause your video, and when you're done, unpause it to check. All right, so looking at this first one, I know it's going to be a fraction. What can I divide them both by? Now, if you did 2 over 12, that's fine, but just know that you can reduce it again into 1 over 6. So I'm going to put a 1 and a 6. Where do I have more x's, on top or on bottom? Obviously on top by 4. Okay? Number 8, you could reduce 14 over 6. I could say 7 over 3. So I have 7 over 3 as part of my answer. And where do I have more x's, on top or on bottom? On top by 5. All right, and that's really it, guys. I have some things to remember. When you have the same number on the top and bottom of a fraction, you can divide it out and make 1. A coefficient is the number in front of the variable. When any number doesn't have an exponent, the exponent is actually 1. Usually, when we are dividing like bases, they will have coefficients in front of the bases. Always reduce these coefficients first. Remember, you're going to have fractions in front of these guys. And really, that's it. Thanks for watching.